My name is Mike DeLaCluse. I'm the president of Lesman Instrument Company. I'd like to thank all of you for taking time out of your busy schedules to join us for our 14th customer webinar. This one is on Industrial Wireless 101, where Chris will give you an overview of industrial wireless technologies. Chris has been around industrial wireless for the past 8 years and has been instrumental in designing and implementing many applications for our customers. He's not only had to put all the pieces together, but he's also had to make it work. We will be muting the phone lines. If you have any questions and would like to unmute yourself, all you have to do is hit *6 and you will be unmuted. If you can save your questions for the end, that would be preferable. At the end, we will unmute everybody, so feel free to ask the question when we do end the session. With that introduction, I'd like to turn the presentation over to Chris.
Excellent. Thank you, Mike. Good morning, everybody. Welcome to Industrial Wireless Overview. We're going to take you on a little journey today of how wireless works, why it works, what kind of information you can exchange via wireless, and I'm going to try and keep it more of an overview and not too much about what we sell. We'll talk a little bit about that. As Mike mentioned, typically people will kick up questions, and we appreciate and encourage questions. We're going to hope to save them to the end so we can keep keep our show on the timetable today for those that want to just get back on with their lives. We'll take questions at the end if that's okay. But if you have a burning question, jump in, as Mike said. So here we go. Our goal in wireless is, of course, to get rid of wires and get rid of the associated costs and hassles that come along with wires. Wireless is about eliminating blind spots and pulling together remote assets. Most of the projects that we've done, and we've done a little bit over 70 wireless projects now over the last period of years, most of them that we've done have been related to remote items out on the back 40, whether it be a tank farm, a pond, an outfall, where people wish they had information that they could bring back to better manage their facility. As wireless has moved forward in more recent times, we're getting more and more wireless opportunities where we're actually controlling, where we're turning something on remotely, not just measuring it. So bullet point 2 here, it's about creating and sharing information with minimal cost, effort, and engineering time. And you'll see as we go along that this equipment has come a long way and is quite easy to get up and running these days. Wireless is about the freedom and flexibility to solve problems and difficult challenges, and we'll talk about it, some common applications. I've got some pictures that I'll show you a little bit later. So in today's wireless world, we've got basically 3 technologies. We've got standard radio frequency radio, RF. We've got satellite capabilities, and we've got cellular capabilities. Satellite only usually comes into play where people have very remote assets, people with pipelines, with very distant tank farms, things like that. It's not a big play, but it is available. Everything that we're going to talk about could be done theoretically via satellite. Cellular has come on strong of late. Cellular is easy. It's easy to figure out if it works. All you need is a phone and check how many bars you have. One of the issues with both satellite and cellular is there is infrastructure cost associated. You have to pay a provider to provide the connectivity. What we're going to focus on today is going to be the radio, the RF. And the beauty of RF is the air is still free. The government has not figured out a way to tax it yet. So once you buy the equipment required to create the communication, your investment is done. There is no infrastructure. So in all these technologies, the huge growth in personal communications gizmos has aided this greatly. They all use similar technology, similar chips, similar capabilities, so the more there is of all this equipment, the more it becomes highly available and lower in cost because there's more competition. So yeah, over the last 6 years for sure, the cost of this equipment has come down significantly. Okay? What types of information could be transmitted? We can do we most often see analogs and digitals, the classic industrial measurement, I/O, if you will. We can also do temperature, pulses, Allen Bradley DF1, DeviceNet, so now we're getting into some more complex communication protocols. Interbus and CAN Open are used typically in the building automation business. We don't see it too much in our classic industrial customer, but it's out there. These guys over here in Profibus, these three right here are by far the most popular, which is Modbus RTU, Modbus TCP, and Ethernet IP. And you'll see as we go along with the various radios that we offer that they do a really good job of integrating all these various communication protocols. The radios are quite smart and quite capable. So when we talk about wireless, it's about replacing the physical layer. The field device and the control system don't really care how they exchange information. They just know that they did. Once the wireless link is in place, as far as they're concerned, it's a piece of wire. What our goal is in the whole wireless game is to eliminate that piece of wire and the associated expense and hassles that go along with actually pulling that wire. When you look at costs, physical things related to wiring, you'll recognize up here in the middle these explosion-proof seals. All these things are expensive. The piping is heavy and expensive. If you have to go through a parking lot, you're looking at trenching, boring, removing blacktop, things that get costly quite quickly. And of course, cable trays, conduits, all the miscellaneous parts that we're virtually eliminating by going with a wireless strategy. Engineering time's a factor. Sometimes if permits are a part of the deal. Often in an industrial environment, if you have to penetrate a wall, you've got to have drawings. We run into situations where the environment's so harsh that corrosion is an issue for the wire itself as well as the connection part of it, the actual termination. So anywhere there's wire, there's people working, there's high installation costs, high maintenance costs, the failure rate is fairly high. So we're virtually eliminating all this from our world. When we decided to get good at wireless about 6 years ago, we saw the trend coming. It's still a little bit early, but we knew, for a living we sell industrial field measurement devices. And it's all about bringing them back in. So we saw the nice connectivity, and that's why we decided to head this way. When you're in wireless, the cost can vary greatly depending if there's electrical unions involved, depending on the area classification that's involved. So first thing we're getting rid of is the wire. So let's press on. So the world's been using wireless for many, many decades. We all trust it every single day for our fire and police service, and it's very robust and very capable. What we're doing here in our wireless is we're using a series of radio bands that the government gave us that are called the ISM bands. They're industrial, scientific, and medical. And you'll recognize the bands once we start talking about the frequencies that they come in, because the exact same bands are used for cordless phones, okay? Not cell phones, but cordless phones that you have around your house. So basically what has happened over time is the industrial manufacturers have gotten together, all working on these bands that the government offered. We'll talk a little bit about the bands. And they've taken the old technology and made it much more robust. So we're talking military-grade electronics. We're talking moisture-proof, vibration-proof. As you can see on the lower right-hand side of this picture here, these look like heavy industrial devices that are designed to live in hazardous environments. Now you'll see that as we go along, there's various pieces of equipment. Some looks very industrial and sturdy, and some of it looks like equipment that you could maybe buy from Best Buy. Please understand as we go along, this is not Best Buy level equipment. Even though some of it is compatible with what you could buy at Best Buy, this is robust industrial equipment designed for a long life and survivability. Okay? This is the wireless band chart that the government puts out at this time. I just wanted to give you an idea where we live. So you'll recognize some of these. So it's very low frequency, low, medium, high, very high, ultra high, super high. We live in the ultra high environment. And if you remember back to the old TVs that had knobs, the second channel, which allowed you to get the UHF channels, that's the band we're in. I don't know exactly what colors we're in there, but we live in that environment. So you can see how controlled the world of this free air of ours is. And the trick is we have to stay within certain portions that we're allowed to by the government. So the frequencies that we're working with are 900 megahertz, 2.4 gigahertz, and 5.8 gigahertz. Those are all controlled by the government. Now the trick in this whole deal is when you're in any of these band ranges, you are not allowed to hog a channel. So all the equipment we're talking about today is considered frequency hopping, meaning it's changing channels throughout its communication, and it happens very, very quickly, anywhere from microseconds to milliseconds. Part of the built-in security of all these strategies is the fact that only the sender and receiver know what channel they're going to jump to. It's called a pseudo-random hopping pattern. So if someone was to stand out on the perimeter with some sort of a scanner, they might see some information being exchanged on a certain channel. By the time they even noticed it was there, it would be gone. So because of the hopping and because of the pseudo-random pattern, and because of the fact that any radio has to be placed into the network, you really don't have to worry about people hacking. We'll talk more about hacking and security in IT as we push along here. So kind of an interesting fact in radio is the lower the frequency, the less data you can send. The higher the frequency, the more data you can send. When we look at a low-frequency signal, in our world, that's in the 900 megahertz band. As we talked about, there is frequency hopping, FHSS, frequency hopping spread spectrum. You might have heard this on a cordless phone, or you may have heard the term before, but all you need to know is we're hopping at all times so that we're not hogging a channel, so that multiple users can share the airwaves. When we're in the lower range of frequency, the 900 megahertz, we are using this FHSS technology, and I'll show you a slide and a couple more that'll make more sense of this. But I put up a picture of a bullet, and the reason for the bullet is to help people understand how data moves. When you take a bullet, a rifle bullet like such as this, and you put it in your rifle and you aim it at 45 degrees up in the air and you fire it, that bullet will go quite far. Okay? All the energy is pushing one single bit of data, if you will. When you take that same rifle, put a bullet in it, and aim it at a wall, there's a real good chance that bullet's going to get through the wall. Depending what the wall is made of, if it's drywall, it's going to go through a bunch of walls. It'll punch through wood, it'll punch through brick. How many walls it'll go through is part of the thing we try and think when we're out talking about where to put radios, where to put antennas. So in this case, that bullet's ability to get through a wall is considered boring power. So our 900 megahertz lower frequency radios have great boring power and great distance. Okay? However, they cannot move a lot of information because you're only shooting one bullet at a time. So to stick with that theme, we move on to the next technology, which is called DSSS, Direct Sequence Spread Spectrum. And DSSS is much more like a shotgun. Okay? So if you look at the green cutaway of the shotgun, there's a whole bunch of BBs that are in that shell that are all being fired by a single load. So to use the same sort of thought pattern, if you take that shotgun and point it up at 45 degrees and fire it in the air, those BBs are not going to go nearly as far as that bullet because the energy to shove them is being dissipated by each of the BBs. So you can move a lot of information, each BB being some data, but you can't move it very far. Now, as far as we go back to boring power and talk about that, if you take a shotgun and point it at a wall and fire it, can you get through some drywall? Yeah. Can you get through wood? Maybe not. Depends how big the BBs are and how big the shot load is. So multiple walls, lots of data, kind of hard to do, and it's a strategy we need to work a little bit differently by managing where we place antennas, etc. So the next slide gives a good representation for the more technical folks in the audience to help you understand why it works this way. So in frequency hopping, you can see that we have a very tall peak, a very powerful shot here, but we can only move a little bit of data where the communication is happening, and on the next one, and on the next one. So there's our boring power, and there's our distance, but not too much data. When you go to the higher frequencies of 2.4 gigahertz and 5.8 gigahertz, and you shift over to the direct sequence strategy, you get a much broader shot, meaning you're moving a lot of data. So now we're talking about Ethernet, maybe camera feeds, maybe huge amounts of I/O. We can move a tremendous amount of data, but we can't shoot it as far because it doesn't have the power behind the shot. And we can't get through as many walls, or it has reduced boring power. So hopefully that's apparent. A lot of boring power, not so much boring power. A little bit of data, lots of area for data during the communication sequence. Okay? How does frequency hopping deal with interference? Frequency hopping was basically invented during World War II and was our way to prevent our enemies from listening in on our equipment. And as I mentioned, it's pseudo-random. Only the sender and the receiver know where it's going to go, and they hop channels. Now, in an environment where people are sharing the airwaves, there is potential for two radios to step on each other. And what it looks like is this, okay? We're communicating, we're jumping around a 900 megahertz band, and you can see at some point there's a collision, and you lose that piece of data. Now, what happens in the real world is when you get that collision, it doesn't mean that you completely lost communication. It means that that bit didn't come through, and the receiving radio is essentially going to say, I didn't hear you, send it again. Okay, so in a situation where you're getting lots of collisions, you'll have your communication slow down significantly. Now, when we go out and talk to people about radio, today there's not a lot of wireless in a typical industrial environment, not a lot. Typically you don't have to worry about it. We do have the ability to go and do a frequency check and then literally go around your location and determine how much potential radio traffic there is to see if collisions would be a concern, if it would slow down communication to the point that there's trouble. And an example of this, when you have collisions and slowed down communications, if you've ever been in a hotel and taken a laptop and they have Wi-Fi and you see you have a really good, strong signal, you might even experience this in your neighborhood if you live in a real congested area. You'll see a lot of different Wi-Fi available to you. It appears as though you have a very strong signal, but you know your communication is slow. And what's happening in that environment is you're getting a bunch of collisions, forcing the receiving radio to say, I'm sorry I didn't hear you, send it again, and then creating latency in your communication. So hopefully that makes sense to everybody. So Ethernet is becoming quite big. Now, of course, we all know Ethernet from Wi-Fi, and we'll talk a little bit about Wi-Fi standards and where our heavy industrial equipment fits in those Wi-Fi standards. But what we're seeing today is more and more workers at the plant level having some sort of communication device with them where they can literally view the process. Sometimes you can even interact with the process and turn things on and off. And if you'll notice, this larger one to the middle right really looks like a modern HMI. And it does give the guy on the floor the ability to, literally press this touchpad and make a valve open or make a motor turn on. Ethernet, because of its ability to handle a tremendous amount of data, is a great way to do this. Our customers are getting more and more interested in cameras. And in the past, cameras were always analog. They had their own system. They had their own pretty complex digital recording setups. Due to post 9/11, people are very interested in who's at the gate, who's at the perimeter, what's at the back fence. So that kind of activity is picked up. Well, with Ethernet, wireless Ethernet, putting cameras in has now become quite easy. You can literally attach a camera to a radio and fire the signal back. We've got people interested in where's the worker, where's the truck, is the process running properly. We worked with a Midwest Gen plant here locally in Chicago that was having a problem spilling coal off of their coal conveyors. And they really didn't have a good way to monitor it because it was upstairs coming out of a hole in the ground. It looks similar to the thing that returns your bowling ball at the bowling alley. Well, when they loaded it improperly, it would spill, which created a hazard because it's slippery, and of course it's a pain. You have to clean it up. All they wanted to do was have cameras down in the control room so that they could visualize these bowling ball return conveyors full of coal. And we were able to easily place 3 cameras at one of each of these coal dispensers, connect them all into one radio, and shoot it across the entire power plant environment. So we're talking about beams, I-beams, pipes, turbines, the whole bit. We could shoot it all the way across in one shot and give them complete, full-speed, clear video on a flat screen right inside the control room. So they were thrilled with that. So keep that in mind as we press forward. Cameras and wireless go together quite nicely because of wireless Ethernet. Okay? So when you start talking about Wi-Fi, Wi-Fi comes in a variety of standards that were developed by the government, and they continue to press forward as things get faster and more capable. So most of you have probably seen these 802.11 type standards. Some of the equipment that we sell is capable of interacting on these standards. So you can make it a hotspot so that guys can use laptops and other Ethernet-enabled equipment wirelessly. You can use it. You can add it together and use traditional I/O and match it with Ethernet. There's a lot of neat things you can do, and I'll show you a couple of pictures a little bit later that'll pull that together better. One thing I'd like you to notice that down at the bottom here, here's our 900 megahertz band, which is our bullet, which we can shoot far and shoot through lots of walls, and we can actually send Ethernet via this 900 megahertz band. Now, it's not very fast. It's only 1 megabit, so you couldn't do video, but you could easily service quite a bit of I/O, remote I/O, or something else that needed to move quickly. Now, these upper bands are all government standards, so this is where the IT department starts to become a little fearful because they'll say, uh-oh, somebody can hack into this. This band here, this 900 megahertz band, is completely proprietary. No standard. Nobody knows how it communicates except for the sender and receiver. So it's super safe in an environment where you have an IT department that's causing problems. So hang on, my headset's dying here. Hang on 1 second, please. Okay, can you guys hear me? Mike, can you hear me?
Yep, perfectly fine.
Okay, all right, sorry about that. Little equipment challenge here. So in this section here, we need to talk about the IT department a little bit. Some of you don't have IT departments. Some of you have large and powerful IT departments. What I want to tell you here is the important thing is involve the IT department early and often if you have one and there's wireless going in. They're early adopters. They like wireless. They use it every day. We all do, in wireless mouses, wireless keyboards, cell phones, Bluetooth. What their concern is that you might be stepping on their signal, okay? And if you get them involved, tell them what you want to do, ask them what their concerns are, they can usually we can overcome them. Often the 2.4 gigahertz band, they're very protective of, and they'll say, I don't want you to use anything industrial on 2.4. That's why we offer both 5.8 gigahertz and 900 megs, so we can work around that opportunity. All this equipment, even the equipment that follows the government standards, the 802.11 standards, does come with the latest and greatest industrial encryption. If someone was to hack it, almost all of it is firmware upgradable, and the IT guys typically understand that. So again, at the end of the day, bring them in early and often, because if they come in late, they can create trouble. If you don't have one, no worries. Now, one thing I should mention back here is I'm throwing all these bands at you, all these standards, proprietary or not. when we go out and look at applications, we're not worried about standards. We're not worried about what range we're going to use, what frequency range we're going to use. We're worried about your application. And we'll look at it from what is the problem, what are we up against, and then the equipment, what standard we use, and all that will be picked based on solving the puzzle that you have. So it's not that you need to be by any means an expert in any of this. That's what we're here for. This is really just an awareness of the flexibility we have in wireless today. Okay? So in wireless, the key to the whole thing is successfully managing the energy. Okay? You throw it and you catch it. That's what it's all about. We need to know how far it'll go, what kind of obstructions we're up against, will the environment cause trouble, and what interference can be concerning. We'll talk about that a little bit here. Range-wise, you can see at the bottom here, we can go up to 23 miles with a 1-watt radio, which is what the most the government will allow us to use in the ISM bands. Up to a half mile, we can do pretty much no problem. We just need to be a little bit careful to make sure that we're doing things right. So we call that success with experience. Okay? Under 1,000 feet, we call electrician's territory. It's literally going to work. And I'll tell you right now, if you're 1,000 feet and the antennas can see each other, it'll work, no problem. When the antennas cannot see each other, it gets a little bit more complex, and that's why we have a lot of gear that we can bring out and make sure things work. We have different kinds of antennas, different strategies on where to place antennas, and we'll talk about that a little bit more as we go. So when you look at wireless reliability, it's all about maintaining the connection. Okay? There are a couple of issues that we need to worry about here. RF attenuation, is something going to reflect it or absorb the energy that we're throwing? Are we going to get interference from something in your facility or from Mother Nature? And how much power are we using to throw the signal? And again, you don't have to worry about power. We kind of pick power as we go based on the application. So the first thing of concern is RF attenuation. Anytime you hang moisture in the air, it's going to consume some radio signal. If any of you have a dish network or a similar satellite TV environment, when it rains or snows hard, your TVs begin to pixelate because you're losing signal and the TV's inventing what it thinks needs to go in that spot. Well, when we're out in wireless world, when we're going to be shooting through the outdoors, we're very concerned with hanging moisture. And what we always try and do is build in a strong fade margin, which is additional power over and above what you need to make your shot to make sure that we don't lose connectivity during an environment like this. Another issue is absorption. Okay? You see on the picture on the left, there's kind of a fuzzy mountain. Well, anytime you look at a big hill or a mountain, which we don't have many of in our world, but they're out there, they're always full of antennas at the top. That's because that rock is not going to let us shoot radio through it. It'll bounce a little bit. We'll talk about that a little bit more. Trees can be a big issue. Okay? The tree on the right is not that much issue because it can't hold any moisture. I kind of think of it as golf. If you were playing golf, you might try and get through the tree on the right. The tree on the lower left, you're not going to get through. And when that tree's full of dew or rain, it could potentially be quite a blocker for our RF signal. The other thing you need to consider is trees change over time. They get bigger. You know, ones that are not in the way when you first start might be in the way in 10 years. So trees can be an issue. Absorption, another issue. Okay, so we don't have mountains, but we do have earthen dikes. We do have hills. We do have river valleys. And the radio will be basically chewed up by it. Sometimes there's elevated water in the form of canals, ponds, things like that. Okay? More typical is what we see in the middle, where we have an industrial environment with a variety of buildings, tanks, silos, etc. Oftentimes we can shoot through them or bounce off of them. The statements in the middle here are just kind of a good overview for things to watch for. Wood, brick, and glass are okay. All right? You can sit in your house or your office and typically listen to the radio. You get way into the building or down in the basement, it can become a challenge because the structure is attenuating the signal. So the second item here, earth and water are trouble because they will eat up your signal. and metal and rock tend to bounce. Sometimes the bounce is good for you and can be very helpful. Sometimes we'll actually work with the bounce. So here's a great example of reflection or multipathing, they'll call it officially. This is a more typical industrial environment. Lots of round objects, lots of square objects. Well, it has a tendency to bounce our signals actually quite nicely. When we go out and do surveys, we find that we can get deep into a tank farm, and because of all the round shapes and all the bouncing, the communication is still quite strong. So when we get into our typical industrial environments, this stuff works very, very well. Okay? Interference. Solar can be an issue with some of the things we do. We're in an upswinging solar cycle now. We were very, very low. Sometimes you'll get a little solar flare action that will impede. If you've ever listened to AM radio during a thunderstorm, you understand how it can impede the signal where you get all the crackles in that. This guy in the middle is a troublemaker, especially old microwaves because they tend to be pretty powerful and a little bit leaky. But through some miracle, if you take 2.4 gigahertz radio energy and focus it on water, it'll heat the molecules. So that's one of the reasons why that's an open government channel, is because of this guy right here. So when we go and do radio surveys, microwaves don't run constantly, so you don't know when they're in there. All I want you to be aware of is if there are microwaves in the building, you need to let us know, because we need to make sure that we can avoid them or shoot over them or around them. So wireless reliability is directly related to signal strength. It's literally how hard we're throwing the signal. The equipment that we have varies from 2.5 watts to 1 full watt. Again, 1 full watt will get you your 23 miles plus if we get the antennas up high enough. The little guy that you put in your ear for Bluetooth, that is a 1 milliwatt radio. So just to give you an idea, it's only designed to shoot 10 meters, how much variation you can have. Again, you don't have to worry about wattage. We'll pick how much wattage you need to achieve what you're trying to do at your plant location. Whenever you talk radio, everybody wants to talk line of sight. Over on the left here, we have a big radio tower. And line of sight was actually originally created to make up for the curvature of the Earth. Okay, when you're putting up 50,000 watt AM radio channels, you need to get them up high or they'll hit the dirt. At about 7 miles in our nice flat Midwestern environment, the curve of the Earth starts to make a difference, and we know how to manage that, and I'll show you in a second. In the industrial world, line of sight more typically means to us one antenna can see the other antenna. And again, 1,000 yards, antennas can see each other. This will work, no problem. We won't even have to come out and try it. Now, when you get down here, where we're going through things and bouncing off things, often we will bring gear out just to make sure that we can achieve and maintain good connectivity. Because at the end of the day, this thing's got to work and work well and be robust and have enough extra strength, especially in these outside environments, to shoot through the weather. In our world, we're often working in and around lots of obstacles. Okay? Radio waves shoot in a pattern that looks like a football or a rugby ball. In the middle, they're at their widest point. If we can put the obstructions in the middle, that'll give us the best chance of achieving successful, robust connectivity. Little rule of thumb here, more obstacles, the less distance, because it's costing us power as it's bouncing and being consumed. If I was to take this tank farm in the middle and push it very close to one side or the other, I may in fact have issues. And then we need to talk about moving antennas and getting around these things. When it's out in the middle, it's typically not a problem in any way. So here's the reality of our world. We call on heavy industrial customers that are full of pipes and tanks and silos and reactors and every other kind of gizmo you can think of. Our industrial wireless works wonderfully in this environment. It'll fire through this stuff. It'll bounce off this stuff. Another general rule of thumb, if you can see a path for a man to walk down or a car or a cart to drive down, the radio will fire right down it very nicely. Radio will work in a tunnel wonderfully as long as you don't go around a corner. If you need to go around a corner, that's when we start talking about a strategy where we include a repeater radio, which does nothing more than catch and resend at full power whatever it sees. Okay? most of the trouble calls we go on related to wireless are related to the antennas. The antennas are either poorly mounted, they fell down, the connections are loose, they were put in the wrong spot. So it's always the antenna. Antenna awareness is very, very important. So I just want to talk about a couple kinds of antennas. This is an omnidirectional antenna, just like on, well, cars have fins now. They used to have antennas, but it's designed to send and receive information in a big circle in all directions. The standard little antenna, omnidirectional antenna, like on your car, actually throws a pumpkin-shaped energy bubble, if you will. It'll send and receive very high, not so wide. Works great when you need to get high from the bottom of the power plant to the top of the power plant. It works wonderfully. Doesn't give you a lot of good reaching distance. This white antenna over to the right is an actual engineered, modified, what they call a high-gain antenna, and it takes the pumpkin-shaped energy and smashes it down. When it does that, it reaches out farther, so you end up with a flat but very far-reaching antenna energy range, as is shown here. Our next antenna, you used to see a lot on houses, but it's called a Yagi array antenna, and it's directional. And essentially, wherever you point it, that's where the energy is going. So you have to think of it sort of like a mag light, okay? It gives you, instead of a floodlight, it gives you a spotlight, so you can directionally control your energy. One thing you'll notice is coming off the back, there's little to no energy. So we like to use Yagi antennas in environments where we're doing a multi-point out on a perimeter to a point in the middle. So you aim the Yagi antennas to one of these Omni antennas in the middle, which is broadcasting in all directions. And the beauty of the Yagi is it gives you good, strong connectivity, but you don't have any energy coming off the left side or the back side, so you're not inviting in radio energy from your neighbors. So it makes for a nice, robust environment when you're working in that design. Occasionally, in some of the higher frequencies, we'll use parabolic dish antennas that give us an even tighter beam. It's like taking your mag light and turning it down to a tight spot. Sometimes this is required in the higher frequencies to get good connectivity. So on occasion, those are out there. You might have seen some that kind of have a specific look to them. Okay? Antennas needed to be mounted properly. They need to be mounted in a very sturdy fashion. We actually sell a self-vulcanizing antenna tape that we encourage all connections are wrapped with. The quality of the antenna wire, the quality of the connection, and the quality of the antenna are all very important to long-term reliability and robustness of your environment. A lot of times we'll see antennas that are hanging down or crooked, and that is not a good thing. People always ask, can you do solar? We absolutely can do solar. Solar can get expensive because along with solar comes batteries, which have to be able to hold enough juice to get you through a cloudy day. Now, in the Chicagoland environment, we are in a very low solar environment, which means large solar panels and big batteries. So we talk solar a lot more than we sell solar, but the guys that live out in the desert and, in the Four Corners and the Rockies, they can use much smaller batteries and panels because they have so much more sun power and so many good solar days. So it is doable. It's just we need to, you're going to be investing a little bit. You're talking, depending on what you need, $2,000 and up for a solar addition to a radio network. Okay? So why wireless? It is by far the easiest way to pull together scattered assets. Now, this is a picture of a steel mill, which is a giant location. The steel mills buy a lot of wireless because they're measuring things all over the place that need to come back in. Our two biggest users are water treatment people that have a lot of scattered assets and steel mills, which have a lot of scattered assets. And they're both big users for many, many years. Okay? So why wireless? It's certainly about lowering installation costs. We've found it can be the difference between a project going through and a project getting mothballed because the impact of pulling wires can be so tremendous on the budget. Faster commissioning. This stuff is very easy to set up. Some of it is a little bit more complex. We'll set it up for you. It is all non-volatile memory, so if you turn it off, it does remember what it's supposed to do. It avoids limitations, certainly. Pay-as-you-go architecture, most of the customers we do wireless jobs with, they come back and they say, I like it, it works good, I want to add this, this, and this. It gives you flexibility towards meeting regulatory requirements, which are always interesting, whether it's an air problem or a pH problem on an outfall or whatever. And it's also about reducing maintenance and operation costs because you can do better monitoring of equipment that you're not in touch with today. So you can look at things like varying temperatures and vibrations. Okay. Eliminate walk-around data collection. There's still a lot of guys with pickup trucks and clipboards that are going out and taking measurements. In some environments, they're going into a dangerous, hot, scary environment. They might have to climb. We can minimize that. And, of course, anytime there's a human taking a measurement, if we can get rid of him, we're going to improve reliability and accuracy. Okay? Common things we use them for, lots of tank level and inventory management. Many people have tanks in the back part of the parking lot that have pumps and lights, but nobody knows what's in them. Energy consumption measurements, environmental compliance tracking. Safety showers is a big one. If a safety or eye wash station goes off, somebody needs to know because somebody's in trouble. We've also done quite a few jobs with wind speed and direction. If the evacuation alarm goes off, they like to be able to determine what the wind direction is to tell the workers which area to go to so they're moving away from any sort of potentially poisonous cloud. Water, wastewater, pump control. Next slide here. Ruptured disc, safety relief valve, steam trap monitoring has become very popular due to some neat acoustical equipment we have. Motor monitoring is getting very big. Through the miracle of RFID tracking, you can track personnel and assets. Mobile equipment is a big deal, and I'll show you a couple pictures here. We do a lot of work on remote back of the plant, back 40, whatever you want to call it, where people have outfalls, lagoons, ponds, creeks. You know, often the government will be monitoring, ask you to monitor things like pH, turbidity, temperature, because if you raise the temperature of the creek, that is pollution. That is temperature pollution. So we do a lot of work in those ways. Those are great spots to use a solar solution where you're not only powering the radio, but you're powering the instrument. Rotating equipment, great thing to do. These are big dryers. We use wireless instead of drag lines. Works very nicely. Mobile or moving equipment. On this John Deere guy over on the right, we have a guy that pumps concrete. He needs to know how much he pumps and at what pressure he pumped it. He's basically working on areas that are going to become landfills. So that was a real nice application we did. We have 5 different types of wireless products, and I'm going to go over each of them very briefly just to give you an idea. This particular one is Phoenix Contact. You can see that the green Slice I/O looking devices are the actual radios and associated I/O. It needs to go in a panel. It's very, very flexible. There's lots of things we can mix and match as far as different types of Ethernet, serial communications, analogs, digitals. Very flexible, very capable. Works great where you have a high density of I/O. Let's say you have 20 to 30 points that you want to gather from one spot and send. This is an excellent strategy. Another vendor we work with is Banner. Banner's excellent at wireless with batteries, where you just don't have the available power or it's a hassle to get power there. Their battery packs are large enough where you can even power some simple instruments. They're smart enough where you can tell them to turn on, warm up an instrument, take a shot, send the information, and then go back to sleep. So you can do some wonderful things with complete wireless battery solutions. Now, I also threw in a solar panel in here. They're very good at solar. A combination of a solar panel and a 6 battery pack like this guy over to the right. There's 6 D-cell deep lithium batteries and deep cycle lithium batteries in there. That combination is not a bad value and is a great way to measure depth of pits, lagoons, things like that. Banner's very good at low-density I/O applications where you have 2 or 3 things that you want to gather in and send. The Banner equipment is very easy to add radios to the network. They do a real nice job. It's a nice fit for us. In our Siemens world, Siemens has decided to embrace the wireless HART technology. And we have a variety of transmitters that are field devices, battery powered, that take the measurement, indicate the measurement, and communicate back wirelessly. What's neat about HART Wireless is this little guy right here, this adapter, provides you the ability to hook it to any device that's out in your plant that's wired and is capable of speaking HART. What this does is unleash the HART. So if you have multivariable transmitters, which are capable of giving you a variety of information, you can only get one thing back on your 4 to 20. Well, if you wire in one of these adapters and communicate back to a base station, now you can pull all the information that is available from that device out. So if you are pursuing a predictive maintenance strategy where you're watching valves age or pumps wear, this is a great strategy to do that. Now, this stuff is designed for only about 200 meters, so this is close proximity, what we call unit-based solution, okay? HART Wireless. A lot of your favorite manufacturers and vendors of instruments are all going to be coming out with equipment with antennas on it. You're going to see mag meters with antennas and vortex meters with antennas. This is moving forward at a pretty nice pace now. Another variation that we have, this is a sensor-based radio network from Honeywell. These are a little bit simpler devices. They're a little better value. We can do temperatures, digitals, analogs. We can do acoustic inputs. You can have up to 100 of these field radios talking to one base radio. Okay, they're battery powered. Depending on how often you tell them to turn on and talk, they can communicate for up to 10 years. There is one highly available, non-proprietary C battery in this guy. And how we have it shown here is we're using a Honeywell video chart recorder, which makes a wonderful Modbus master. It's talking Modbus to this guy, and then it's going out and saying, hey, temperature sensor 1, what's your input? And then we're charting it. So that's just a nice little package that we do. An upscale version of that from Honeywell is what they call their X-Wire 6000. This is another local field instrument network that's designed to work around a variety of tanks or a reactor vessel area. These things are about 1,000-foot shot. This version works on ISA 100, which is a little different than a wireless HART. It's kind of like beta versus VHS. I don't think either one's going to win. I think they're both going to survive. All you need to know is they're similar. They both have their features and benefits, if you will. We have both available. Also up here, they have a wireless adapter that they call the finger, and you can kind of see why. It will give you the ability to tie existing HART equipment into this network. Okay. Now here's the granddaddy. This is the X-Wire 6000 full-blown. This gray box at the top, which you've seen a couple other times in my PowerPoint here, actually acts like a cell tower. It's called a multi-node. It has 3 radios built in. The black radio on the bottom communicates out to the battery-powered, industrial, very accurate and capable field devices. The antenna on the right will throw Wi-Fi, so you can literally create a Wi-Fi hotspot within your plant. This antenna here communicates to other wireless multi-nodes. So it's kind of like putting cell towers up in your environment. So I'm going to come over to my graphic on the left. The dots are our multi-nodes, our cell towers. You can literally light up an entire plant and end up with essentially a wireless cloud. Okay? So now you're talking about redundancy, self-propagating, self-healing. I mean, this thing's got it all. If you put a new device in, it recognizes it. This is the future, we think, where the world is going. But we've got it. We've got it today. So I'm running a little bit long. I'm running a lot long. When we take a long shot, we have software that allows us to see the curve of the Earth in blue, the actual topology of the environment in green, the radio shot, the lower half of the football in black, and this is the line of sight between the antennas. So we can accurately determine where and how high to put antennas for a long-term outside shot. We have the ability to put together everything you need, put things in boxes, do the configuration. We do everything but the physical install on the wireless. All you have to do is hang it, put power to it, and you're in business. We provide all the pre-sales and post-sales support anybody would potentially need. Okay? So I'm sorry I went so long. Why not wireless? People fear it. The stuff, if we do it right, it works good. It's very robust. People that try it like it, they want more. Most people fear it because it's bleeding edge. It's not. It's leading edge, meaning if you do it right, it works. Security nightmares, because of the frequency hopping, because of the proprietary protocols, where really this is not an issue. If you have a super paranoid IT department, we can get them over it typically. Again, if you have IT, involve them early and often. Licensing problems, there are none. No licenses are required for these ISM bands. Okay? The next revolution in manufacturing will be built on information. Wireless is going to be a part of it. And our thought for today is, if you can't control, you can't control what you don't measure. Okay? So that's the end. Mike, I don't know if you want to unmute people.
Well, Chris, thank you very much for your presentation. If there are specific questions, we'll take them in just a moment, or you can give myself or Chris a call at 800-9-LESMAN. Later today, you'll get an invitation to join our LinkedIn forum. The forum's a way to keep up to date on our upcoming webinars, as well as place posts for questions and connect with others that have attended some of our previous seminars. When we do schedule a new session, LinkedIn's one of the first places we post it. Our next webinar is going to cover what's new in industrial wireless technologies. Chris covered in that Type 4 and 5 some of the stuff that's coming. You'll get an insight into evolving standards, both current and evolving field instruments that are being brought to the market. We sit in a very interesting position. Most of your instrumentation vendors will only have a single standard to discuss. In our case, we have Honeywell developing products for ISA 100, while we have Phoenix Contact and Siemens developing products for wireless HART. This gives us the ability to talk about the strengths and weaknesses of both without really being partial to either. Our presenter for that session will be Dan Wisey. If you've never heard Dan speak, he has the ability to distill information down, allowing you to maximize your learning in a short period of time. That webinar will be held on Tuesday, August 30th at 9 a.m., and you can sign up at lesman.com. At this point, I am going to unmute everyone. Okay, everybody's unmuted. So if there are any questions, feel free to ask away. Did the unmute work?
Yeah, it did. I'm going to say we have no questions.
Okay, if there aren't any questions, that will conclude our seminar. If you do think of some in the future, feel free to give Chris or I a call, again at 800-953-7626. Thank you very much for attending.